Local AI is getting ridiculous good with models like Qwen 3.5, but the VRAM requirements are insane. But before you drop thousands of dollars on an RTX 5090, wait. Whether you have a single GPU with just a few gigabytes of VRAM or already own one of the more powerful 16GB cards, there's a cheaper path and it actually works. After Nvidia cancelled the expected 24GB GPUs, I was looking for an affordable way to finally run larger LLMs at decent speed. And I found it. A second-hand GPU for just $200. The Intel Arc A770 with 16GB of VRAM, a card that's been underestimated until now. It works as a standalone GPU and it works even better in a multi-GPU setup with a combined 32GB of VRAM. I'll show you both in this video, including the performance data. And of course, as promised in the last video, with Qwen 3.5 and this time with the actual 35B MOE model. Before we get to the benchmarks, let me show you what the setup actually looks like and what I had to figure out along the way. My previous X570 board didn't survive the build. I'm not sure if it was the installation or a pre-existing issue, but it's gone. The replacement B550 paired with a Ryzen 7 3700X and 32GB of DDR4 3200 only provides PCIe 3.0 at X4 for the second slot instead of PCIe 4.0. Loading the model takes a bit longer, but once it's sitting in the VRAM, the bandwidth to the slot is irrelevant. A couple of things to keep in mind if you're planning something similar. Put your faster GPU in the slot closest to the CPU, that's typically the X16 slot. The second slot is usually X4 and that's where the A770 goes. Also, check the physical space between your slots carefully. Modern 16GB GPUs are thick, and after installing both cards, I had only 3 to 4 mm of clearance between them. Depending on your board layout, the second slot can also be very close to the case edge or to your RAM, worth checking before you buy. I don't overclock. For AI inference it barely makes a difference anyway, so I don't bother. That keeps thermals manageable. I added an extra fan to my case given the tight fit, but many current cases already have enough airflow built in. One more thing for Arc GPU users. Make sure both above 4G decoding and resizable bar are enabled in your BIOS. Do not skip this, you will leave significant performance on the table. To give the Arc 770 and our dual GPU setup something to compare against, we start with my AMD RX 6800 with 16GB VRAM running alone. In LM Studio's hardware settings, I'm selecting only the RX 6800. Runtime is Vulkan. The AMD ROCm version of llama.cpp showed no advantage on my system, and by the way, there's no Arc-specific llama.cpp backend in LM Studio yet. More on that in a moment. I'll run two model types, a dense model and a MOE model, mixture of experts, so you can see how each architecture performs. For the dense test, Qwen 3 14B Q4KM quantization, context length 4K. The model takes up around 9GB including KV cache. I'm using the same test prompt I've used in my benchmark video and my last video. If you want to understand how to evaluate whether a model fits your hardware, the link is in the description. 40 tokens per second. For reference, with 512GB per second of memory bandwidth and a 9GB model, the theoretical ceiling is around 57 tokens per second. 40 is a solid result. For a rough comparison, I found at Hardware Corner. An RTX 5060 Ti 16GB hits 41.1 tokens per second on the same model at the same context length. These are different systems with different drivers and setups, so treat this as orientation, not a direct benchmark. Still, the RX 6800 is right there. Now the MOE model. Qwen 3.5 35B, this is where the mixture of experts architecture actually kicks in, as several of you correctly pointed out in the comments on my last video. Thank you for that. The GGUF quantization here is UDIQ2M from Unsloth, found on Hugging Face, around 13 GB. I choose this because it just barely fits in 16 GB of VRAM. Quality doesn't matter for this test, this is pure performance. 75 tokens per second, almost double the dense model on a larger file. That's the MOE advantage. Only the layers relevant to your prompt are actually activated. Same model, same prompt, now on the Arc A770. One important thing before we start. Disable flash attention in LM Studio. With it enabled, you will get garbled output towards the end of the response. This applies to LM Studio 049 with current Intel drivers. Disabling it costs no meaningful performance on my machine. Qwen 3 14B Q4KM, around 25 tokens per second. That's less than 2/3 of the RX 6800. The A770 does have dedicated matrix multiplication units the RX 6800 lacks, but in LM Studio we can only use Vulkan llama.cpp, which doesn't seem to make use of those. So is this the best this card can do? To find out, I converted the Qwen 3 14B model to Intel's OpenVINO format using a small Python script. OpenVINO is Intel's own AI inference framework. The Int4 converted model is roughly the same file size as the Q4KM GGUF. Result, just under 30 tokens per second, about 20% faster than LM Studio Vulkan at lower GPU utilization. That means the A770's dedicated AI hardware is being used here, but not through LM Studio. For a rough orientation, the RTX 4060 Ti 16GB sits at 27.4 tokens per second on the same model, again according to Hardware Corner, different environment. The A770 with Vulkan lands just below that, OpenVINO puts it just above. Again, different systems, different drivers, treat this as a ballpark only. For the dual GPU setup in this video, we'll stay with LM Studio and Vulkan, but it's worth knowing this headroom exists. Qwen 3.5 35B MOE on the A770. 50 tokens per second. Double the dense model, 2/3 of the RX 6800 on the same model. Consistent pattern. One thing to be aware of if you're running a secondary GPU without a monitor attached. After a period of inactivity, LM Studio unloads the model from that GPU. This is a Windows PCIe power management behavior. The GPU enters a low power state and LM Studio treats it as unavailable. If this happens to you, check your Windows power settings under PCI Express Link State Power Management. Now the actual point of this video. Both GPUs together and models that neither card could handle alone. In LM Studio's hardware settings, both cards are enabled. KV cache offload to GPU memory should be on, you want that for speed. For the split strategy, I only get split evenly with this mixed vendor setup. More granular control appears to be available for dual NVIDIA configurations, but not here. Runtime, Vulkan only, it's the only backend that supports both cards simultaneously. That's fine, it's the faster option on my system anyway. Dense model first. Qwen 3 32B Q5KM, about 23 GB. This would not fit on either card alone. Higher quant than the solo tests, because now we can. The split lands at 12.8 GB on the RX 6800 and 11.5 GB on the A770. Very even, including the monitor overhead on the 6800. Flash attention off as always when the A770 is in the loop. 13 tokens per second, above reading speed on a 23 GB model that otherwise wouldn't run at all. That's the point of this setup. Now the MOE model, Qwen 3.5 35B Q5KM, about 28 GB. One thing, make sure GPU offload is set to maximum. I missed that on my first attempt and got around 15 tokens per second, barely above the dense model result. Once that's corrected, reload and let's see. 50 tokens per second on a 28 GB model. I also checked the output. For my benchmark prompt, this model would get full marks. The answer was correct and complete. So 28 GB, 50 tokens per second, full output quality. That's what this setup delivers. So where does this leave us? The Arc A770, a second-hand GPU for $200, holds its own as a standalone card. With LM Studio and Vulkan, it runs Qwen 3 14B at around 25 tokens per second, roughly in the range of a current mid-range 16 GB Nvidia card. With OpenVINO it gets to just under 30 using the dedicated AI hardware that Vulkan currently doesn't seem to reach. And on the MOE model it hits 50 tokens per second, double the dense model. Combined with the RX 6800, 32 GB of VRAM, models up to 28 GB, 50 tokens per second. For a total GPU investment, that doesn't come close to what a single flagship card would cost. If you're sitting on a 16 GB GPU and wondering whether a second card makes sense, the answer depends on what you want to run. If your models already fit comfortably, one card is simpler and often faster. But if you want to go bigger, this is a real and affordable path. Now here's my problem. The dual GPU setup works. Not just for local AI, it also gives me a small but noticeable boost when editing video, which puts me in a bit of a dilemma. I had originally planned to move the A770 over to my mini PC via OcuLink, an external GPU connection that behaves like PCIe without the protocol overhead of Thunderbolt, and test what that looks like for local AI, including the integrated GPU. But right now I'm genuinely not sure I want to give this up. So I'll let you decide. If that mini PC OcuLink setup sounds interesting to you, iGPU inference, external GPU over OcuLink, how it compares to a full tower setup, let me know in the comments. If enough of you want to see it, that will make the decision easier. If you found this useful, my other videos on how to evaluate whether a model fits your hardware and on GGUF quantization are linked below. Thanks for watching.